now we practice, right? Now we practice. We're going to integrate a bunch of indefinite integrals. Here's our first one. I am integrating 3x to the 5th plus 2 minus 5 square roots of x dx. Just like when we did our derivatives, I'm going to keep bringing this up because there's a lot of similarities. As soon as you see a radical, what did you do? Change it to that exponent, right? Same thing. We're going to do that again. So I'm actually integrating 3x to the 5th plus 2 minus 5x to the 1/2 power. Don't forget your differential. Got to have that differential. All right? Got to have that differential. Okay. Now we integrate because we have exponents. Plus 1. So then this is going to be 3x to the 6th. And then I bring this 6 in front as the denominator. Plus, and anytime you just have a number, I'm not going to go through and add 0, like x to the 0 plus 1. Anytime you just have a number, know that you're going to put that variable next to it, right? Taken from a 0 exponent to a 1 exponent. We already talked about that. Here, whenever I add 1 to this, get that common denominator. So I now have 5, and I've got x to the 3/2. What happens whenever you divide by a fraction? You multiply by the reciprocal. Exactly. So I'm going to multiply that by 2/3 because I'm dividing. So what I'm technically doing here is I'm taking 5 divided by 3/2, which is the same thing as 5 times 2/3. But we're not going to write that extra step because why would you? Right? We know we're dividing by that. Multiply by that reciprocal. Okay, clean it up. So I've got 1/2 x to the 6th plus 2 minus a 10/3 x to the 3/2 plus c. Don't forget that plus c. Got to have that because you don't know about that constant there, right? Okay, now, just for fun, because I think it's good when we start off with this, let's check. We're not going to do this again. This will be a one-hit wonder here. You're not going to go through and check it every time, but it is nice to say, oh, let me double check this, make sure that this is something that I can go backwards with, right? Because that's an antiderivative, so I can check myself. So take the derivative is what we're doing here. And we're going to take the derivative and using differential notation. That's why we learned it, ladies and gentlemen. So dy is now equal to, bring that 6 in front, giving me a 3, subtracting 1, x to the 5th. And then, oh, look at me. You guys are hollering at me, and I so appreciate you. I'd forgotten my x there, didn't I? It didn't just disappear. That's on me. Sorry. And then here, let me go back to blue. So now if I take this derivative, I just have a plus 2, right? And then I bring that in front, minus a 10/3 times 3/2 x. Whenever I subtract 1 from that, I get x to the 1/2 power. And then I've got dx. So when I clean this up, dy is now equal to 3x to the 5th plus 2. So the 3's cancel. 2 goes in there 5 times. So minus 5 square roots of x dx. That's my differential. All right, so if I'm writing a differential, let me squeeze this back in. You can see where that comes from, right? Okay. Okay, and it's back to the same thing. All right. All right. And we know the derivative of a constant here is 0. So it's the derivative of this constant is just 0, so we don't write that in there. So we're not going to check all of these as we go through here, but I just thought, you have room? Yep. I just thought while we've got one, let's just check it. Because we're learning. That's part of learning. Let's look at example 2b. I want to integrate 4x to the 19th minus 5x to the negative 8 over x squared dx. Do I have a quotient rule for integration? No, you do not. No, you do not. So because you don't, what do we have to do here? Algebra first. Divide this monomial into each one of those terms. So I'm actually integrating 4x to the 17th minus 5x to the negative 10, right? Because when you divide exponents, you subtract. And it gets us there. Now we have everything in terms of plus or minus. We just have terms here. So now you integrate with that power rule. So add 1 to each one of these. And then we integrate. So I've got 4. And I like to write this as x to the 18th and then put that underneath it. That's just how I like to write it. I'll do my exponent first and then I put it underneath there just so that I can stay hip on what's going on. Minus 5. Now this is x to the negative 9 divided here by negative 9. And then of course your plus c. Now clean it up. 2/9 x to the 18th plus 5/9 x to the negative 9 plus c. And you can go ahead and just leave that negative exponent. There's no reason to change that to a positive. And putting it in the denominator doesn't do anybody any good. Just leave it like that. Cool. Let's try one more here. We have example 2c, where I'm going to integrate z squared plus 1 times 2z minus 5. And what's my differential going to be on this? dz. Yes, because that is the variable that we're using. Don't just get in a rut with your x's. It's good to spice it up a little bit here. So good. Okay. Do I have a product rule? No, we do not. So what do? Yes, just multiply it out. Good. So I end up with 2z cubed minus 5z squared plus 2z minus 5 dz. Now everything's in terms of plus or minus. I've got my power rule. Add 1. And then I know that's just going to be my variable there. Add 1 and divide by that coefficient. So I've got 2z to the 4th divided by 4 minus 5z cubed divided by 3 plus 2z squared divided by 2 minus 5z. And then what do we have to have always? Plus c. Good. Just clean it up. 1/2 z to the 4th minus 5/3 z cubed plus z squared minus 5z plus c. And that's what there is, ladies and gentlemen. That's the power rule. There is no product rule. There is no quotient rule. You have to algebra first. Right? You have to algebra first. So get in the habit of that. You can do this.